I flew 5,000 miles to Shenzhen, China to visit high-volume injection molding factories just like this one.
The city is just insane, like insane.
We had to learn how to design physical hardware from complete scratch. 3D printing doesn't really scale. MJF is perfect for, let's say, a couple hundreds of units, but if you scale it up to 10,000, the per part cost is just way too high. You have to transition to injection molding. But making a custom steel mold locally, it's incredibly expensive. Shenzhen has an entire ecosystem built for this, so I had to go there. Dominic stayed back to hold the fort, so I made the trip solo. After a long flight, I hit the ground running to meet our potential manufacturing partners in person.
We just got to Shenzhen, our first supplier, so yeah, we're about to visit the enclosure manufacturer. That's some of our suppliers now, and they're so nice. They picked me up, and we have Coco here. Hello. She's helping us today. She's been taking care of our project, so we'll have a look. Okay.
Hey guys, real quick before we get into the video, first off, if you haven't watched part 1 of this series yet, I highly recommend pausing this video and go back to check that out. I will link it up right here. It'll really help you to understand exactly how and why would transition a project from 3D printing over to the injection molding side. Now, since that first video got such an awesome response from all of you guys, we actually reached out to our injection molding supplier and to see if they want to actually sponsor part 2. And graciously, they said yes. Even better, we worked out an exclusive deal for those of you who might be looking for a off-the-shelf or custom housing for your project. I will share all the details later on, but for now, let's get back to the video.
English?
Whatever. It's okay.
After that, Coco switched over to Chinese to give us the full rundown. You can see the floor is pretty packed today. She explained they're actually in the middle of shipping out a few massive orders. And off to the left is their post-processing area. We also walked past their packaging station for smaller parts. She mentioned larger assemblies happens upstairs. And right in front of us are their massive storage racks. Right past the storage, we got our first real look at one of their heavy-duty setup. Coco explained that while this ground floor is mostly geared towards running smaller batch orders, this massive machine right here is dedicated to mold much larger parts.
That's a huge machine.
Seeing the scale of it in person is really impressive. She also dropped a cool piece of manufacturing inside. If you're doing injection molding in China, the 2 powerhouse machine brands you will see dominating the factory floors are Haitian and Izumi. Right next to that massive machine, Coco pointed out a small pile of raw materials staged for production. This part of the conversation was super relevant for our own quality control. She explained they mostly use brand new plastics rather than recycled ones, because recycled plastic can be brittle and cause defects. They mostly source their pallets from top-tier suppliers like Chime from Taiwan or some German brands. It really just comes down to the exact toughness and specs the product needs. As we kept walking, Coco led us towards the row of active machines to show us their quality control setup. Each station has its specific work procedure and product info display. And every single machine has a dedicated worker monitoring the output. She broke down the exact workflow for us. Inside the machine sits the custom mold, and once the plastic is injected and cooled, the mold will open. An automated robotic arm will grab the finished parts and drop it right in front of the worker for a full one-by-one inspection. Getting up close to the freshly molded parts, Coco walked me through exactly what the operator is looking for. They're checking for any rough edges, warping, or big surface scratches. Passed parts go straight into a bin, and rejected are tossed aside, meaning every single piece gets 100% visual inspection right off the press. But what really stood out to me is their layered quality control. This station is just the first line of defense. After this, another worker does a secondary check, followed by a roaming floor quality inspector who does a 20% random spot check on the batch. And just to be completely safe, everything gets looked over one last time during packaging to make sure zero defects parts make it out the door.
So the whole process, including the actual injection molding, and also every part will be actually monitored, let's say, or visually inspected and individually. So 100% of the yield. As you can see, she's actually looking at the parts and one by one, and then they will actually package it and then do all the inspections. So it's pretty cool. And she mentioned this is the kind of machine that we'll be using if we want to do high injection molding. You can see there's the arm. It actually places it takes up the actual part and then places it into the box. So as you can see.
哎 ，hello， 你好，你好，
你好，你好，
你好，这是我们厂长。你好，你好，辛苦辛苦。下楼。
A little further down the floor, we were introduced to the factory's production manager. He came over to greet us and asked if we were more interested in their standard products or their mold making capabilities. Coco explained our exact situation. We were already using some of their off-the-shelf housing, but we're really here because we need a custom mold for our current project. Hearing that, he gave us a proper breakdown of the floor. This specific area runs 6 injection molding machines, ranging from a 120-ton setup to a massive 380-ton machine. He explained that these 6 are actually dedicated to smaller orders and testing out brand new molds, while the high-volume mass production happens upstairs. The actual mold making workshop was right next door. But before we heading over, he actually wanted to give us a closer look at their biggest machine in this section, which turned out to be that exact same 380-ton green machine which I was admiring earlier. The manager gave us the full technical rundown on this setup. As their biggest machine in this section, it can mold single parts weighing up to 900 grams. But what's really interesting is the custom specification they ordered this machine with. Even though it's a 380-ton machine, they had the working area expand to fit the outer shell of a 450-ton mold. They did this specifically to accommodate unusually long parts for one of their clients, which just showed a really great level of manufacturing flexibility. While we were talking over the machine specs, Coco grabbed one of their freshly molded pieces right off the line for me to check out. It was actually still warm in my hand from the injection process.
还是热的。
是啊，它注射出来，其实在里面的话，那个材料等于是注射进去之后它会保压嘛。
Standing right in front of that big green machine, I told the manager how impressive the setup was, and he gave us some really honest industry insight. He explained that domestic machines like the exact one we were looking at had gotten incredibly capable. He was totally upfront that if you need ultra-fine microscopic precision, some factories still lean towards Japanese or German equipment. But for heavy-duty, high-quality production, brands like Izumi and Haitian are absolute workhorses. They are the top 2 brands in China, and he mentioned they are also massively popular in places like India and Russia. After wrapping up our chat by the big green machine, we finally headed next door to the main event, the mold making workshop. On the walk over, Coco gave me a little bit more context about the layout, explaining that this entire area is actually one massive industrial park. She told me they've been getting so many orders lately, they're occasionally running out of floor space inside. So they have to temporarily stage raw materials and finished products around the building just to keep up with demand.
It's insane. It's just like an industrial area. They have like source, like raw materials over there. Things are just piled up. It's just, they got a lot of stuff to do, which is pretty cool. And this is now the mold area. Wow.
Stepping into the mold making workshop, the vibe completely shifted from mass production to heavy duty precision engineering. The manager explained that they've actually handled about 90% of all their mold fabrication right here in-house. The only process they outsource are highly specialized steps, like laser texturing or specific chemical surface treatments. Everything else happens right on this floor. He walked us through their setup. They have a dedicated CNC area handling the bulk of the heavy steel cutting, alongside EDM and wire cutting EDM machines for ultra-precise details, plus standard milling and grinding stations. Coco also made sure to highlight their tooling quality control. They have a dedicated dimensional measurement area equipped with CMMs, coordinate measurement machines, to ensure the steel molds are cut to the exact dimension before any plastic ever gets injected.
It's insane. So for surface finishes and for some laser stuff, they probably get it done externally, but the rest they actually do it all here. So which is pretty impressive.
Before heading deeper into the shop, the manager pointed out a few heavy mold assemblies sitting on the workstation. He explained that when a mold hits these tables, it's in its home stretch. This is where they hand-fit the final mechanical features like sliders and springs, right before their first injection test runs. He also broke down the testing timeline, which usually takes 3 to 4 trial stages, known in manufacturing as T0 through T3. All of that initial tweaking and perfecting happens right here, while future routine maintenance is handled next door on the main production floor. We made our way across the rest of the shop floor and finally stepped into their dedicated CNC room. Now, if you're new to manufacturing, you might be wondering how a raw block of steel actually becomes a custom mold for our products. That's where CNC machine comes in. Think of it like high-tech sculpting. A computer controls a fast-spinning cutting tool that carves away a solid block of steel. It precisely mills out the main cavities and broad features of our mold, doing the heavy lifting to get it very close to its final shape. Back on the floor, the manager broke down their specific setup for us. They run 5 CNC machines in total. 3 are high-end Japanese machines and 2 are domestic models that are dedicated strictly to cut smaller parts. He pointed out their massive high-speed machine in the back and dropped an interesting technical detail. Despite the complex geometry they cut, all 5 of these machines are standard 3-axis setups. Leaving the CNC area, I asked the manager if these machine basically runs 24/7. He laughed and told me that if you walk around this entire Dongguan industrial area, about 70% of their workshops operate exactly like this, running 2 full shifts, day and night, just to maximize machine time. He explained that some of these cuts takes hours to finish, so if you only run a day shift, you'd only finish 2 or 3 parts before everyone goes home. But the CNC drills around, they physically cannot cut perfectly sharp, square internal edges or corners. To get those complex DFM features and sharp corners, the factory actually used a completely different process, which is called EDM, electrical discharge machining. Instead of cutting the steel with a drill, they literally burn the exact shape into the steel using electrical sparks. A custom-shaped copper or graphite electrodes is lowered towards the mold. It never actually touches the steel. Instead, it uses a rapid-fire barrage of microscopic electrical sparks to erode the metal away, perfectly stamping its shape into the mold.
Look at this stuff.
Back in the shop, the manager pointed out their specific setup. They have 3 of these specialized Surface EDM machines lined up, sitting right alongside 3 standard EDM machines to handle all the intricate finishing work for the molds. While we were checking out the setup, Coco brought up a really important point about manufacturing costs. She explained the difference between a standard EDM and what the industry calls a mirror EDM or fine finish machine. A standard EDM cuts faster but leaves a slightly rough matte texture on the steel. A mirror EDM uses incredibly tiny precise spark to slowly erode the metal, leaving a perfectly smooth surface, but because it takes much longer, it drives up the cost of the mold. While their domestic fine finish machines are great, if a factory uses ultra high-end Japanese or German equipment, that spark erosion is so precise, it literally leaves a mirror finish on the steel. The manager then pointed across the aisle to their standard EDM machines. He explained that the main difference really just comes down to precision. The fine finish machines have much tighter computer control, which creates that perfect surface. So if a final product doesn't actually need a highly polished look, then just use standard machine to save time and money. I joked that he must be talking about our products, which got a good laugh. But to give a real-world example of what that premium mirror EDM finish is absolutely necessary, he pointed right at the DJI camera I was filming with, specifically the ultra-smooth plastic around the lens housing. A huge thanks to Shenzhen OMK Electronics for sponsoring today's video. As you have seen, they are incredibly capable injection molding experts. They handle over 50 global projects a year across IoT, agriculture, medical and consumer tech. And they have serious expertise in tricky structural design, especially waterproofing, shockproofing, IP-rated enclosures. Because we love working with them, we've got you a deal. Put NK Tech in your email subject line to get a free simple DFM report for your custom enclosure. And even better, if you order a custom mold with them, they will do their structural design, including that complex IP67 or 8 waterproofing, completely free. I really wish we had this kind of deal when we started. They also have awesome off-the-shelf enclosure for prototypes, which we actually use for our own gateway devices. Their website and direct email are linked in the description below. So pass this along to a friend who might need it, and let's get back to the shop. Heading into the next room, we finally got to see their wire EDM machines. They even separate them. The slow wire machines uses special liquids and filtered water for extremely high precision cuts, while the faster wire machines handles the standard cutting stuff. If you have never seen one of these in action, here's how they work. Imagine a high-tech cheese slicer. A hair-thin electrically charged wire is fed completely through a starting hole in the metal block. Then a computer precisely drives the heavy steel block into the wire or guides the wire around the block. Just like Surface EDM, it uses tiny electrical spark to vaporize the metal right in front of it as it moves. It slices right through the thickest steel with microscopic accuracy, which is perfect for cutting out complex and straight-walled shapes. Back on the floor, Coco explained that wire EDM basically falls into 3 categories: slow, medium and fast. It's a direct trade-off between speed and precision. The slow machines are insanely accurate but takes forever, leaving a superior finish. The fast ones gets it done quickly but leaves a rougher cut. And the business side is fascinating. Jumping up a tier doubles the price, meaning a high-end slow machine costs roughly 4 times as much as a fast one. The manager broke down why they are so different. A high-end slowed machine is sensitive. It requires strict climate control, air conditioning and water cooling. Meanwhile, the fast and medium machines are so rugged you could literally set them up in a tent outside. He pointed inside one of the fast machines, and the liquid looked completely dark. And that's actually oil acting as cooling. It's filled with microscopic vaporized metal dust from the sparks. Slow machines, on the other hand, uses crystal clear water. Even the cutting wire itself is completely different. The fast and medium machines uses a super strong molybdenum alloy wire, while the high precision slow machine uses pure copper. Basic physics are exactly the same across the board, but seeing the engineering differences up close is honestly just so cool. Next, the manager took us into the next room to see the high-precision slow wire machine. The difference is night and day. Instead of that dark, murky oil we saw earlier in the other room, this machine uses crystal clear water. But he explained that you can't just use tap water. It has to be highly filtered, deionized water to ensure electrical sparks are perfectly controlled. While these machines usually live in high-end clean room for aerospace kind of work, he told us that for our level of precision, operating them in their standard workshop still gets the job done perfectly. Coco added that they mostly reserve this machine for tiny, intricate parts like high-precision connectors. To put that into perspective, the manager gave us the actual numbers. While the fast machine next door are accurate to about 5 to 10 micrometers, this machine here can hit a staggering 2 to 5 micrometers. That is roughly 20 times thinner than a human hair. Seeing that level of precision in person really makes you realize the engineering depth required to build even the smallest component of our product. As we were wrapping up in the mold making shop, I was curious about sheer volume of production they handle. So I asked how many molds they currently have on site. The answer was staggering, between 1,000 and 2,000 active molds. Coco clarified that these fall into 2 categories. There are stock molds for their own off-the-shelf enclosure, like the one we used for our gateway devices. And then there are private molds, which are custom built and exclusive for specific customers. With that much steel mold to keep track of, they have dedicated storage area spread across both downstairs and upstairs floor just to manage the inventory. Once the steel mold is finally cut, polished and assembled, it heads to the production. Depending on their size, it either moves to next door to the massive high tonnage machines or upstairs for the smaller ones. This is where the magic actually happens. While we were heading towards the production floor, the manager gave me a deep dive into mold maintenance, something most people completely overlook. He explained that maintenance is driven by two things: storage time and operation time. If a mold sits in storage, they crack it open every 3 to 6 months to replace the oil and check for rust, especially during the humid summer months. But the operation-driven maintenance is where it gets really technical. After 50,000 to 100,000 injections, the steel actually starts to build up internal stress from the constant heat and pressure. To prevent cracking or deformation, they actually pull the mold through a tempering process, heating it up to 400 degrees and letting it cool naturally to reset the steel. He told me that with this kind of disciplined care, a standard steel mold can last up to 1 million shots. However, he noted that if you want to do that ultra high gloss or mirror finish we talked about earlier, you would have to start with specialized high strength corrosion resistant steel from day one. Coco and the manager then tied all those maintenance stats back to our specific project. Since we're looking at an initial run of maybe 20,000 to 30,000 units the first year, they actually recommend sticking with the standard steel. It's significantly cheaper than the high-end alloys, but it's still durable enough to pull 200,000 to 300,000 shots without breaking a sweat. It was reassuring to hear them suggest a cost-effective path that doesn't compromise the actual quality of our parts. After soaking up all that knowledge on steel and maintenance, Coco suggested we'd head upstairs to see the rest of the operation. I took a quick moment to talk to the camera and summarize everything I've just learned. It's a lot to take in, from microscopic precision of the EDM machines to the long-term strategy of mold tempering. The ground floor is where the tools are born, but upstairs is where they really get to work.
It's just lots of insane information, so I gotta have to process this afterwards. So it's just, I even have to look into some other stuff, but it's quite insane what's going on over here.
Walking onto the second floor, the manager gave me the numbers for this section. They have 32 injection molding machines running up here, which is much bigger setup than the 6 machines we saw on the ground floor. He mentioned that 2 of them at the very back are 280-ton units, while the rest are a mix of sizes ranging from 80 to 200 tons. As we move towards the next aisle, Coco gave me some perspective on their production mix. She explained that parts requiring those massive machines are actually the minority. The bulk of their work is for smaller parts and components, very similar to the size of our tag housing. So she also noted their flexibility. If a customer's project eventually requires a part bigger than what their current line can handle, they're actually willing to invest in a larger machine to make it happen. The manager mentioned that they maintain a 2-shift 24-hour cycle up here as well, but with a strategic twist. They don't actually run all 32 machines at full capacity during the day. To stay efficient, they take advantage of the off-peak power incentives offered by the local grid. This means they schedule their biggest and most power-hungry machines to run primarily during the night shift when the electricity is cheaper. It's a smart way to keep their overhead down, which ultimately helps keep the production cost lower for us as well. Tucked away along all these high-tech setup, I spotted a real piece of history, an old manual injection machine. It's a total contrast to the 32 automated units surrounding it. On a machine like this, a person has to manually pull the lever to clamp the mold and inject the plastic. It's essentially the analog ancestor of the massive hydraulic giants we were just looking at. It's not used for our production, of course, but seeing where the technology has started make you really appreciate the speed and precision of the modern machine even more. Moving further down the line, we saw the manual side of the process. Coco explained that these workers are responsible for removing the gate waste from the freshly molded parts. Even with all this automation, you still need a human touch to cleanly trim away the excess plastic that solidifies in the channel leading into the mold cavity. A few steps away, I spotted a bin full of these plastic leftovers. I asked Coco if this was the waste, she was just talking about, and she confirmed it. It's essentially the skeleton of the injection process, the part that gets the plastic into the mold but isn't part of the final product. Seeing the pile of it really gives you a sense of just how much volume this floor is pushing out.
这次就可以实地考察。
对，我现在听过的东西，现在就是这个东西。
图文是吧？
对。
看起来啊。
As we turned to walk back, I noticed a worker at one of the stations inspecting some high-gloss parts. Right next to her was this small handy device used specifically for checking optical transparency. The manager showed me how they use it to test the parts right there on the spot, ensuring that even for these clear components, there are no internal cloudiness or defects that might have been missed during the molding process.
就知道了，就做熟了就知道。
The manager spent the next few minutes walking me through their entire development and quality control lifecycle. It's the kind of high-level procedural stuff that's vital for a factory to run smoothly, but probably a bit dry for the vlog. Essentially, they have a rigorous paper trail and testing phase for every step of the mold life.
没问题了，我们就做表面处理，到 T2、T3，我们出样品之后发给客户，客户认为这个产品。
With the technical deep dive officially out of the way and our tour wrapped up, it's time to head back out and process everything we've seen today.
I just got done at 4:30 p.m. Now I just got out of the office because we went to the first fill suppliers. We went to their factory, then came back. That was in Dongguan area, so we came back to Shenzhen. That's where their office is. It's actually right at the heart of the Huaqiang Bay, which is basically the mecca of electronics, right? So it's been a crazy day, seeing so many things, and then we talked about so many things that, you know, stuff that we can source from them or get it done by them, and some pricing and some. It's just very productive. And then they drove me back here. We had lunch, had some more discussion. Now I'm just kind of I'm trying to get to the Huaqiang Bay area, which I am actually already, but to the market. So that's kind of where I'm heading to. But if you look, the city is just insane, like insane. The city is hustling and bustling. And look at this place. Look at this area. There's just all of these shops around here. It's just all sorts of electronics and what have you. And you got all this. Look at this. Look at that. So this is where all the stuff is happening, at least in terms of electronics. So, yeah.
So that is the dream. Millions of parts rolling off an assembly line. But here is the terrifying startup reality. We haven't actually pulled the trigger on our tooling yet. Right now, we're in the middle of massive beta trial using these tough 3D printed MJF tags, because kicking off a mold is one of the biggest financial bet an early stage hardware startup can make. If you write bad code, you can just push an over-the-air update to fix it or quickly recompile it and things like that. But you know, if you mess up a steel mold, you throw it in the trash and you lose tens of thousands of dollars. I went to Shenzhen to find the right partners and validate our designs. But right now, we're still going back and forth with their engineers on the final microscopic DFM details, as we talked about. And we're waiting to see how the cows actually treat our current beta hardware before we lock it in. Hardware is brutal. If you want to see if our prototype survives the hurt and watch us make the terrifying decisions to finally pull the trigger on the tooling, hit subscribe and see you in the next one.
Oh, it's already recording. Yeah, so is it recording? Yeah, I think it's recording.
Meine Güte, es ist wieder am Laufen.